Good morning, Math 174. Here's your test review for the series chapter. You should have available for study your sample test questions, which I gave you last week, and also your homework that you should have been doing, and certainly the 3 quizzes that we've looked at, because I said that I would take the test questions off, quiz 1, 2, 3, 4, and the homework. So no new problems. Okay, so we start off with if you look at the sample test, we start off with a question dealing with sequences and series. And so these 2 questions right here, and a little bit about their ratio and convergence. Those nicely come out of section 9.1 and 2. 9.1 was sequence, and 9.2 were series, in particular the geometric series. I like these sample test questions so much I just may throw those right at you. So those questions are problem 1 you should probably be able to handle. Okay. The second thing on the sample test was the geometric series. And you should be able to handle geometric series. I particularly like the ones in the text and the ones on quiz. You might want to look at quiz number 2, question 3. Now, it was nice because it had a negative common ratio. So R, I think there was negative 2/3. And certainly you're going to have to know the formula. I'm not going to give it to you, although it is on your table of convergence for typical series. But yeah, you should know this by now, that the sum of a convergent geometric series is A over 1 minus R. Okay. P series was the next one on your sample test. P series. This was a nice little P series. I think it was similar to a quiz question. You might want to look at the homework. Both. Extend this down here. Let me just pull up a new page here. Homework, section 9.3, number 35. That had to do with P series. Quiz number 2, question 5. That had to do with P series. So yeah, be able to convert radicals to P expressions and determine convergence or divergence. Next question on the sample test was one having to do with, let's see, with convergence. This is number 4 I'm looking at. Use any test to determine the convergence of this particular series here, n squared over n squared plus 1. Well, I mean, obviously we talk about the nth term test for divergence. Nth term test. And certainly if you have an n squared and an n squared plus 1, that's going to go to 1 as n gets really big. So that automatically says any series of that ilk, n squared over n squared plus 1, must diverge. Okay, so the nth term test for divergence, you'll see a question like that. You should also be aware that in the nth term test, here's your sample test again, your nth term test will not work if, let's see, okay, so here's a number 8, this P series 1 over n. Take a look-see at quiz number 3. This was an interesting question, number 3 here, where it has n over n squared minus 1. So the nth term test does say that if the nth term goes to something other than 0, here it goes to 1, then we get divergence. But if you had 1 over n, we know that goes to 0. And the one on the quiz that we were just looking at, n over n squared minus 1, that also goes to 0. But this doesn't give you any conclusion. Remember, no conclusion possible. The nth term test says if the nth term does not go to 0, as it does up here, then we get divergence. If the nth term does go to 0, we don't get any conclusion. But you should know something about the good old harmonic series, right? 1 over n. That diverges. That's a p series with p equal to 1. So divergent p series. And anything that looks like that in form would probably diverge. So if you look at this, you have n to the first, and you've got n squared. Now it is true there's a minus 1 there, but in the limit, as n gets really big, n over n squared minus 1 is going to behave like this, right? N gets really big of 1 over n. So using a limit comparison should get you a good handle on a series like this. So just sort of take a look-see at that. Make sure you understand how the limit comparison test works. Okay, back to the sample test for a sec. We were talking about a series that had some factorials in it. So if you look at question number 6, use any test to determine convergence of this particular series, where you've got 4 to the n and n factorial. So you should know that a ratio test deals with series and factorials. So if you had a series with a factorial in it somewhere, typically in the bottom, I think we did one on quiz number 3. Let's look at that. Yeah, okay, so look at this guy here. I mean, here's a series that has an n factorial in the bottom, and up top there's a quadratic and an exponential and sort of a linear term down in the bottom. But certainly anything like that, where you have that n factorial, you're going to be using the ratio test to do that. Okay, so we did do that on quiz number 3. Make sure you look at that problem. I know there were some other problems in the problem set that dealt with factorials in the ratio test. Ratio test is going to be used a couple of times on this test to make sure you understand. Now look at this one, number 6, for example. That's a ratio test problem. Number 7, it says use the ratio test, where you have n over 2 to the n. I think that was very similar in flavor to homework problem 19 in section 9.6. I think that was n over 4 to the n. And again, just using the ratio test to analyze that. Okay, back to the sample test questions. Let's see, definition. Well, I told you you would have number 9. Okay, so number 9, that was the first question on quiz number 3. It was the first question on quiz number 4, and it will be a question on your test. You just have to know that. So go to quiz 3, write the definition of the Taylor polynomial centered at C. First 5 terms, the nth term, finite series, no ellipsis at the end. So make sure you're able to complete that. We also did it on quiz number 4, the exact same question. Write the definition of the Taylor series. Now this one slightly different because the one on quiz 3 said Taylor polynomial and it was finite, so it stops. But the one on quiz number 4 was the series, right? So this is an infinite series. So you have the nth term and an ellipsis at the end. Polynomials, Taylor polynomials. Square roots are nice. In fact, I think that was one of the homework exercises. I know we played a little bit with it on the quizzes, but if you look in section 9.7, number 27, that was dealing with the square root function. I think in that homework problem, they centered it at 4. There's nothing wrong with the number 4. I sort of like numbers like 1 or 100, so that when you actually, you know, I'll give you, just like on the quiz, I'll give you the first few derivatives. There's no sense in wasting time in doing that. So, you know, there's your function, and there's your first derivative, 1 over 2 square roots of x. And there's your second derivative, which is -1 over 4 square roots of x cubed. And your third derivative. I don't think for test purposes we need to go much beyond that, as to test to see whether or not you know how to do that. Square root of x to the 5th. And putting a number like 1 or 100 in for x makes it particularly nice. When you put a number like 4 in, that was the homework problem. It's not bad. These denominators involve 2 raised to various powers, but it's particularly nice with 1 or 100. So once you get the polynomial, you'll be able to do an approximation. I think if we looked at our quizzes, there was an approximation in this problem, but that was a rather obscure function there. So I think quiz 4 had a nice square root. Yeah, and I asked you to approximate 1.1, square root of 1.1. So you'd be putting 1.1 in. You might want to, you know, if this were centered at 100, could you approximate the square root of 103? Or if it were centered at 1, could you approximate the square root of 1.03? It's almost the exact same numbers. I've just moved the decimal point. Okay. Okay, for the power series, again, look at your sample test. You needed to do something about write out the first few terms, tell me the center, use a ratio test to determine the radius, and one of them has an interval of convergence. And all of those problems were out of 9.8. They had a nice set there. You might want to try, I don't know, 9.8, 13, 15, 17. Those problems like that would be nice to practice with. 9.8, numbers 13, 15, 17. Because I think in there you have one of each type that you could analyze. Answers are in the back of the book. You can play with that. Okay, what else is on the test questions? Elementary functions. So yeah, I'll give you the list of elementary functions, the Taylor series, in your text. They're on page 670. I'll just photocopy that. And for your test coming up, I said I would pick something out of the homework. These exercises start on page 673. So if you're looking at your text, page 673. Exercises starting with number 27, where you have to use the table to create a Maclaurin series for a function. And you might want to try the first couple of those to see how they go. Yeah, 27, 29, 31. Those are good problems to play with. 31. I'm not going to get terribly complicated here. Remember, we only have an hour and 15, 20 minutes for the test. Okay, so that should get you sorted out. If you have any deep questions, feel free to email me. I should be available up until class on Tuesday night. So we'll look for you then.